Hello everybody, welcome back to my channel and welcome back to yet another exciting content on technology. This is going to be the fourth part of the four-part video series on building a multi-agent system. So if you have directly popped in here, there is a gentle request to go back and check the first three parts. I'm going to leave the link to those parts in the video description below. So what are we going to focus on this part? We're going to stitch together the three agents that were built so far. The first agent that we had built was to retrieve information from a Flask API hosted locally. The second agent that we had built was to retrieve information from a PDF document using the agentic RAG framework. And the third agent that we had built was to generate an email based on the information collected from the first two agents. In this particular video, we're going to stitch all of them together and monitor them using Langsmet. Thank you very much for tuning in and see you in the very next section.
Welcome to this section of the course. Let's start by reviewing the solution architecture as always. As you can see, these are the three agents that we have built so far: the fetch employee data, generate answer from company policy, and the generate email template. Now it is time to build the last and the supervisor agent. This supervisor agent has no action on its own. All it does is a coordination job among all these four tools or agents. I keep using the term agents and tools interchangeably because every tool behaves like an autonomous agent in this case. So the responsibility of the supervisor is to get the user context and then decide which all the agents that should come into action and in which order. Let's see it in action. On my VS Code, this is the py.env file or the notebook file that I'm going to use. As always, the first step is to invoke the .env file, wherein I'm going to load all the environmental variables from the .env file into my session. The next task is to load the PDF document. Now, I'm not using the data which has already been loaded into my ChromaDB from the previous notebooks because I just wanted to make sure that I can run this file all alone. I'm going to restart the environment so that the documents are reset, and as you can see, I have to traverse back 2 steps up so that I can get the leave policy document. Once I run this, the splitting is all done. The next thing is to store the data or to store the embeddings into my vector store, which is a local ChromaDB. This works. And finally, we are here to define the three tools one after the other again. The first tool is generate answer from policy. Now, if you see the definition of this particular tool or the function, it is absolutely the same which was there in my third notebook, which is the read policy agent. Coming to my second tool, which is the fetch employee data, this is again the same tool definition which was used in the very first agent, which is the fetch data agent. I am just accumulating information in bits and pieces from each of the previous notebooks in this final notebook. If you have not looked at the first employee data agent, I sincerely request you to go back and take a look at it because I have explained the purpose of this employee identity class. The employee identity class is used to read the JSON data from the Flask API and then give an output as individual elements and not a JSON. Finally, I have the generate email. Now the generate email takes input the number of leaves, total encashment, and the purpose. This is again exactly the same function representation as you have seen in the email agent with graph or the email agent notebook. Now that I have all the tools listed out, it is time for me to go ahead and create the React agents. Now for each tool, I'm going to create a single React agent. So I have the policy agent, I have the email agent, and I have the employee agent. As you can see, the model is the same model. Well, I can use a different model, but then for each of these tools, I'm using the same model. Here in the tool section, I'll just use only one tool for each of these agents. So these agents are individual autonomous agents. And finally, I have the workflow, which is being defined as the create supervisor agent. And in the create supervisor agent, I'm using all the three agents together and leaving the choice of these tools to the supervisor. So I have the policy agent, I have the employee agent, and I have the email agent. And here in the prompt, I have made everything clear. You are a leave agent system responding to the employee queries. For fetching employee data, use the employee agent. For answering questions related to the company leave policy, use the policy agent. And to write an email to the medical practitioner, use an email agent. Now, in this case, I don't think it's an email practitioner. I can mention is an HR supervisor, right? But then in my previous execution, it did understand that, the HR supervisor or maybe the medical practitioner, the email template remains the same, right? Fair enough. At this point of time, let me just go ahead and execute all these functions. Then it is time to define every individual agent and the supervisor agent. Let's try to execute a prompt. Now, let me tell you, even the best model is hallucinating as of this writing. So I had to try out multiple permutations and combinations of the prompt to make it work because all are three parallel agents, right? Now, the LLM cannot decide when to execute what. It knows what all the inputs are required for a particular tool. However, it cannot understand the dependencies yet. So if I have to get the email agent, I need to wait for the employee data agent and I need to wait for the get policy agent to fulfill first, get the information, and then pass it on to the email agent. This is something which it is not able to do it. What it is doing is it is firing all the three agent calls in parallel. And then when it goes to the email agent, it finds out, hey, I do not have all the information required for the email agent as yet. So what it does is it goes back to the supervisor, it waits, and then it invokes it again. Right? We will see this hallucination. So finally the output is okay. So the agent is able to think through it. It is able to understand the question and it is able to understand the completeness of the answer and then deliver the answer. But then it is going through multiple iterations before it arrives at the final answer. And this is something which you will see. So I'm using the 3.5 Turbo GPT. I'm not really sure how exactly the other models are going to behave, other reasoning models are going to behave. But then I can see that there's a strong requirement to formulate your prompt in the most appropriate way to get the best answer and the quickest answer. Let me go ahead and execute this. So it takes about 30 seconds to find out the answer. You see that fetch the employee details like earn leaves and salary for the employee with username this. So it's going to use this username to get the employee details first. Fetch the formula to calculate the employee leave encashment amount from the employee leave policy document. Do not assume. Now here I could see that on multiple trials, what the LLM is doing is it is trying to pull the leave encashment formula which is commonly used in the industry. Because it's an LLM which has been trained over multiple documents, it knows what is a very commonly used formula. So instead of doing an agent call, it is actually going and assuming something, which is not incorrect because the assumed formula and the formula which is there in the document, they are the same. but I really do not want it to assume, because given a choice that I can modify the formula in the document, I would want the agent to read the formula only from the document and nothing from anywhere else. So that is the reason I had to mention do not assume. And when I mentioned do not assume, it understood that, okay, fine, I need to focus on the document only. Then use this formula to calculate the leave encashment amount for the employee. Fair enough. And then once you have all the information, write an email to be sent as a leave encashment request to the HR manager. Now, over here, you can see that there are two API calls. Ideally, there shouldn't have been two API calls. This is just a print statement, and because I can see there are two print statements from the fetch leave data, I can understand that there are two API calls. I'm sure what has happened. The first API call did not give it the right answer. The supervisor understood that, okay, the first API call was incorrect. That is why I need to revisit and ask the agent again to fetch correct information from the API data. Let's go ahead and see it in action. I'm just going to print the messages, and let's go ahead and see what all the messages have worked. So the first thing is fetch the employee data. Fetch employee data like earn leaves and salary with the employee. This is what has gone to the supervisor. The supervisor has rightly transferred it to the employee agent. Now in the employee agent, there's something wrong. What has happened is, to calculate the employee leave encashment amount, I need specific formula from the company's leave policy document. This is incorrect, right? You shouldn't have gone to the employee agent to pull the specific formula. So that means the agent has hallucinated here. So what it has done is, if the company policy states leave is basic information like leave days, it has hallucinated here. So it is understood this is not right. Again, it has gone to the employee agent. This time, from the employee agent, it has gone to the supervisor back. The supervisor is sending it to the policy agent now. You see this? The employee is gone to the policy agent. To calculate the leave encashment according to the employee policy document, now it has rightly pulled the formula from the employee policy document. Okay, now I have the formula. Let's go ahead and craft the email. But before it goes to the email, it has again gone to the employee agent. This time, from the employee agent, it has actually pulled the values. To calculate the employee leave encashment amount, we will use the provided formula. Fair enough. It has replaced the details, given the details like basic salary, earned leaves, and it has rightly pulled the documents this time. It has applied the right values for basic salary and earned leaves, and it has calculated the final amount. So you can see that it is not doing it right at the first instance, but it has the intelligence to learn from its mistakes. And finally, it has gone back to the employee agent again, transferring back to the supervisor. Here is the email. You see, this is the final content that has come up. HR manager, I hope this finds you well. I am writing to formally request the encashment of the accrued leaves. Encashment is for an amount of 32,500 for number of 15 leaves. Fair enough. This is fair enough. So I can see that it has multiple times gone ahead and created the email, and the final email that it has come with is this one, wherein it has also highlighted employee name, basic salary, earned leaves, and this. The reason is, as I was saying, so I have three agents. At what point in time, which agent should come into action, and at what point in time I need to wait for another agent to fulfill the activities is something which the LLM is still hallucinating. Now, I think it's time for us to go and take a look at Langsmith. So whatever I just said, you should be able to see that step by step in Langsmith. So if you go to Langsmith, you can see that there's a transfer to the employee agent first. If I go to the employee agent, you will see in the output, it is, I don't see any output, right? Attempt to render message, render the payload, received by. So it has gone to the employee agent, but then the fetch employee details was, the fetch employee data function was invoked on the second instance, not on the first instance. If I go here, see the output, it has got the output, right? Going forward, move to the supervisor, gone to the policy agent. Then there was a policy call. Yes, there was a policy call. It could understand the policy from here. Monthly salary equals to this to be encashed. There was again, it went back to the employee agent, and there was an employee agent call again, correctly got the data. Then finally, it went to the email agent, generate email. It did generate the email, but it was not happy. So it went again, and finally it generated the email one more time. I don't see the generate email call twice. No, I can see the generate email call only once. Let me go back here and try to find out generate underscore email. I don't see that call. Generate underscore agent underscore agent. The first one was an employee agent, okay, the employee agent transfer to policy agent. Then there's the employee agent once more. Then I can see the employee agent, email gen. Okay, so it was an email agent. So if I go here, you can see there was an email agent, fair enough. So it actually went to the email agent twice. Fair enough. Now, there are ways to control this. So right now you have a supervisor, and the supervisor is doing this information exchange among all these nodes. Now in the next video, we will try to cover wherein we will see how a node itself can communicate to other node without the supervisor agent. So once it goes to the fetch data agent immediately knows it is time for me to go to the policy agent. So that is how you can avoid the supervisor taking the decision and every node or every agent passing the request to another agent directly. Right? So that is something which is good to learn. Maybe I'll do some experiments in my upcoming videos. But until then, thank you very much for being a lovely audience and the patient listener. And I hope this was meaningful and you understood how multi-agents work in reality, right? And if you have really liked this kind of video and if you want me to bring in more such content, I would sincerely request you to use the feedback section. Go ahead and write about your learnings. Go about and write what all the different experiments that you are performing, and maybe you can give me a homework as well. Happy to hear back from you. Until then, bye bye.